Hello everyone. In today's topic, we are going to talk about U substitution with definite integral. So let us have the first example. So supposing we are going to find the integral of 2x times x squared plus 4 to the second power dx from 0 to 2. The first step is to let u be equal to x squared plus 4. And then we are going to have the derivative of u. So du is equal to 2x dx. We always write dx after we get the derivative. So from here, we are going to solve for dx. To solve for dx, we are going to divide both sides by 2x. So dividing both sides by 2x, we are going to have du over 2x equals dx. So from here, we are going to substitute our u as well as our dx. So it will become 2x times u squared. And then your dx will become du over dx from here. Simplifying further, we can cancel 2x. And then it will become the derivative of, or the antiderivative of u squared du. And then in the u substitution, we have our lower limit and the upper limit. So to get the lower limit, the new lower limit, we are going to use u is equal to x squared plus 4. And then we are going to substitute the old lower limit, which is equal to 0. So u is equal to 0 squared plus 4 equals 4. So 0 plus 4, it is equal to 4. So we are going to write it there. So our new lower limit is 4. And then to get the new upper limit, we are going to use also the u is equal to x squared plus 4. We substitute the value of our 2, which is the old lower limit. So we get 2 squared plus 4, which is equal to 8. So we will be writing our new upper limit, which is 8. Then we are going to have the integral of u squared du from 4 to 8. So in here, we simply integrate first u squared. So we have u to the third over 3 from 4 to 8. And then we are going first to substitute the upper limit. So you know this one already, the process of integrating. So we have 8 to the third over 3 minus 4 to the third over 3. So 8 to the third is equal to 512. Then 4 to the third is 64. So we have 512 over 3 minus 64 over 3, which is equal to 448 over 3. Because we have the same denominator, we just need to subtract the numerators, which is 512 minus 64. So the final answer in here, 448 over 3. So let us have example number 2. We are going to integrate for x squared root of 16 minus x squared dx from 0 to 4. The first step that we are going to do, u is equal to 16 minus x squared, and then we are going to get the derivative of u. So du equals negative 2x dx. From here, we are going to solve for dx. So we are going to divide both sides by negative 2. So du over negative 2x is equal to dx, or dx is equal to du over negative 2x. From here, we are going to substitute our u as well as our dx. So the result, we have 4x times the square root of u du over negative 2x. Now, let us have our new lower and the upper limit. So to have the new lower limit, we are going to have u is equal to 16 minus x squared. So 16, substituting 0. So 16 minus 0 is 16. That is our lower limit. And then for the upper limit, it is 16 minus 4 squared. which is equal to 0. So we have the upper limit, the new upper limit, which is equal to 0. And as you observe from here, I already canceled for -2, which is equal to -2. As well as the x, it's being canceled already. So since we have a constant here, I already wrote it before the integral symbol so that it will be very easy for us to integrate. So substituting the lower limit and the upper limit, so we have 16 to 0. So in here, we are going to integrate first u to the 1/2. In doing this, so it will be equal to u to the 3 over 2 over 3 over 2, but because we have to get the reciprocal of that, get the reciprocal and then proceed to multiplication, which is the rule in fraction. You all know that already. And then times -2 to be evaluated from 16 to 0. So in here, we are going to substitute the upper limit first, which is equal to 0, then the lower limit. In order for us to integrate, or it will be very easy for us, we can simplify -2 times 2 over 3, which is equal to -4 over 3 before we are going to substitute. So now, it is being simplified already. We can substitute. So we have -4 over 3 times our upper limit, I should say. So 0 to the 3 over 2 minus the lower limit 16 to the 3 over 2. To solve for this one, we have 16, 3 to the 3 over 2. It is equal to square root of 16, this one, to the third power. And square root of 16 is 4. And then 4 to the third is 4 times 4 times 4, which is equal to 64. So therefore, we have -4 over 3 times, since it is minus, so it is minus 64 or -64. In here, multiplying further, we get positive 256 over 3. That is example number 2. Now let us have example number 3. We are going to integrate 2x over 1 plus x squared to the third power, dx from 1 to 2. So sometimes it's difficult to read integration. So bear with me. And then the first step, we are going to have our u. Let u be equal to 1 plus x squared. I got it from the denominator. And then we are going to have the derivative of this one. So du is equal to 2x dx. And then we are going to solve for dx. So we are going to divide both the equation by 2x. So we will be getting du over 2x equals dx. And from here, we can substitute our u and then the dx. So it will become 2x over u to the third du over 2x. From here, we can cancel 2x. But before that, let us have the u first, okay? The new lower limit. So we are going to use u is equal to 1 plus x squared, and then substitute your lower limit, 1. So 1 plus 1 is equal to 2. And then for the new upper limit, we are going to substitute 2. So 1 plus 2 squared is equal to 5. And from here, we can cancel already 2x. It is equal to 1, so no need to write. So we have the antiderivative of u to the -3. Why -3? Because if we have 1 over u to the third, and then we are going to write u at the top, so the exponent will become negative. So we have u to the -3 du. So from here, we can integrate already. So it will become u to the -2 over -2. Because -3 plus 1 is -2. From 2 to 5. And then we are going to make our exponent positive. So we are going to write it in the denominator. So it will become negative 1 over 2u to the second power. So it is positive already. So from here, it to be evaluated from 2 to 5. Then, if to simplify further, we can have negative 1 half times 1 over u squared, which is in the long run, it will be very easy for us to solve. So from 2 to 5. Now we are ready to substitute. So it is equal to negative 1 half times 1 over 5 squared, the upper limit first, minus 1 over 2 squared, the lower limit. So simplifying further, we have negative 1 half times 5 squared is 25 and 2 squared is 4. So we have 1 over 25 minus 1/4, which is equal to, so we are going to multiply 1 over 25 by 4 over 4 and then 1/4 by 25 over 25. Why we are doing this one? So that we shall have the same denominator. So negative 1 over 2 or negative 1 half times 4 over 100 minus 25 over 100. Since we have the same denominator already, we can subtract 4 minus 25, which is equal to negative 21. So we have negative 1 half times negative 21 over 100, which is equal to positive 21 over 200. Okay, so let us have the last example. So we are going to find the antiderivative of sine squared x cosine x dx from 0 to pi over 4. The first step that we are going to do here is to assign u. U is equal to sine x. And then to get the derivative of this one, du is equal to cosine x dx, because we all know that the derivative of sine x is cosine x. From here, we will not anymore derive the value of your dx, because as you can see here, cosine x dx, cosine x dx. So it will be very easy when we immediately substitute the values. So it will become, the sign will become u. So u squared, then cosine x dx is equal to du. So du. And then we are going to have our lower limit. So using your u is equal to sine x, substitute the value of 0. Sine 0 is equal to 0. And then for the upper limit, we have to substitute pi over 4. So sine pi over 4 is equal to square root of 2 over 2. And then we can integrate u squared. So u squared, when we integrate it, it will be equal to u to the third over 3. And to be evaluated from 0 to pi, or to square root of 2 over 2. So from here, we are going to substitute the value of your upper limit first before your lower limit. And when we substitute your lower limit, it is automatically 0 already. So from here, we are going to simplify this one. It would be equal to square root of 8 over 8. Why square root of 8? Because this one will become 2 to the 3 over 2. So get the, then 2 times 2 times 2 is equal to 8, and then the square root of 8. So we have a square root of 8. Okay? So in here, simplifying further, we have, since we have a square root of 8 over 8 times 1/3, so the reciprocal of 3, it will be equal to square root of 8 over 24. Simplifying further, square root of 8 is equal to 2 square root of 2. And 24 is 2 times 12. We can simplify. We can cancel 2. It is equal to 1. So no need to write anymore. So the final answer is square root of 2 over 12. So that's it for now. Please do your practice. the Wiser That Me worksheet number 3 in the Google Classroom. Thank you for watching. See you again next time. Bye.